Well, hello everyone, welcome back to Dprieto TV, and welcome to the grand finale of Prietology Season 5, and not just Season 5, but of Prietology itself. This is the final episode of the Prietology series. Wow, what a journey we have been on for these past 4 years, making now 5 seasons of Prietology. So yeah, welcome to the series finale and the season finale of Season 5 of Prietology. We're on episode 8 today. Today we're talking about the universe. Today we're talking about like the Big Bang Theory, dark matter, what even is all that stuff, and astronomy for the future. What does the future of astronomy hold? Now, here in 2024, and maybe in 2104 or 2124 in 100 years time, but we'll have to see what it looks like. So, since it is the series finale, there's going to be a lot of stuff going on, not just today's episode, but we got other stuff. We got compilations, we got special things that we're doing, and yeah, there's a ton of special stuff to celebrate the series finale, Prietology. It has been such a journey. It's been such an amazing adventure. We have done so much Prietology in the past 4 years. I've enjoyed it a lot. I hope you guys have as well. So today we are celebrating all that as we finally conclude the series. This is the last episode of it, and do not miss it all. So I hope you enjoy it. So yeah, I see no reason to keep talking. Our lava lamp is at full speed. We got everything ready. So yeah, let's start off Prietology Season 5 Episode 8 as usual and go over the key terms. So, here we are everyone, the series finale of Prietology. We have started every single episode, now all 30 episodes including this one, with this, the review of our key terms. So, let's go over our key terms. We have only 5 terms today in today's finale, but we got a lot of other stuff. Pay attention to these final terms that we will do. The final 5 terms in Prietology of the Big Bang and W map, dark matter, dark energy, and space-time. So yeah, let us get started. Alright, so as we start to look into the future, there we go, you can see me. We're not looking into the future. Let us start with all the way back at the beginning of the universe, the Big Bang. You have heard this many, many times. There's even a show about it which doesn't really mention the Big Bang Theory at all. It's a comedy, really. But yeah, the Big Bang Theory is how the universe was created, and supposedly, according to scientists, it occurred about 13.7 billion years ago. So we have been around for a good long while, and some of the galaxies that we have in today's galaxy, especially like some of the local group, have been around for that long. And we have had a lot of stuff happen in our universal history, a lot of things being created. Some things, like say like galaxies or stars, are older than others. The Big Bang created all matter, all forms of energy and order in the universe. So before the Big Bang, there was a lot of like entropy. We've talked about entropy before, I think in Season 2 with physics. Go check that out if you want to. We talked about entropy there, and that's like the measure of disorder, the measure of chaos in the universe. With the Big Bang, all that was put in order, and uniformity was created, and things like planets were created, things that were uniform orders of matter were created with the Big Bang about 13.7 years ago. One thing that helps explain the Big Bang, of course, it's a theory. It's not been proven yet because you can't literally go back in time and check. It's a theory that there was like a little cluster of energy, and then all of a sudden it just bang. It's all matter, all energy, everything that we have in the universe just went out, and then the universe was created. So that's essentially that in a nutshell. It helps explain things like redshift, which we talked about last time, which is a really interesting concept, how light bends as a planet reflects light and it heads towards us. It's sometimes a different color because it loses energy, and this goes more towards a red in the electromagnetic spectrum, which is why planets or stars aren't usually the color that we see them in. And it also helps explain that the universe is constantly expanding. The universe is expanding at a rate as we can't even imagine. It's always expanding, and so those planets are going to get dimmer and dimmer and dimmer as they get so far away. But don't worry, that will happen for a billion years. So yeah, that's what the Big Bang Theory helps explain. The actual bang of the Big Bang Theory occurred in a fraction of a second. So imagine all that energy and then just boom. Universe. Done. You have your universe created. It doubled in size with the Big Bang in under 1 trillionth of a second. 1 over 1 plus, give me a second, 15 zeros. 1 divided by 1 followed by 15 zeros. So that is that much of a time, probably even shorter than that. The universe just doubled in size after the Big Bang, so it's a pretty fast bang. Fun fact about the Big Bang, the initial temperature of the Big Bang, I don't know how we got this reading, but I'm guessing through like celestial bodies and complex math and something like that. The actual Big Bang, the initial temperature of the actual explosion had a temperature of 1 times 10 to the 34th power degrees Celsius. So imagine that 1 followed by 34 zeros. That is a massive amount of energy. The amount of energy that was expelled is probably boiling hot. It would just, yeah. It was a giant explosion. Alright, so how scientists really analyze things like the Big Bang or things that occurred a long time ago, you need something to analyze that, right? Say hello to WMAP or WMAP or WMAP, however you want to say. It stands for the, here, I'll type it right here. It stands for the Wilkinson Microwave Anisotropy Probe. That's what it stands for. The Wilkin Microwave Anisotropy Probe, which can measure the heat of the ancient universe. That is really its main goal. It measures the heat and the leftover energy recreated from the Big Bang from the ancient universe. It was launched in June 30th of 2001. So it has been in space for more than 20 years now. 23 years. Right, I can do math. 23 years it has been in space, measuring the heat of the ancient universe. If you ever wonder where we get that number of 13.7 billion years ago, it comes from WMAP. I'm going to call it that. It comes from WMAP, and it comes from the Wilkinson Microwave and how we get this measurements from the WMAP is that it measures something called the cosmic microwave background. The cosmic microwave background. It measures that. That is how it's able to date the universe and measure the oldest remnants of heat left from the Big Bang. So, like I said, the cosmic microwave background is essentially like a visible glow that can be seen not in the universe, but, well, in the universe. It's a visible glow that can be seen in the universe that are leftovers from the Big Bang. So, very, very, very old heat, that all the matter that's being expelled, that was expelled from the Big Bang, the cosmic microwave background is that remnant of the Big Bang. So how the WMAP works is that it takes samples of irregularities it finds and then it compares it to the norm. So all the irregularities of heat that it finds in the ancient universe. So it's like, oh, this one seems a bit, this is at a different temperature than this one. This is supposed to be. And yeah, so it takes that irregularity and it stores it and it sends it back to Earth for more analysis. The equivalent of this essentially checks every single grain of sand in the Sahara Desert. The amount of work that this does is equivalent to checking every single grain of sand in the Sahara Desert. It would take millions of years. It would take you thousands of years. Fun fact, the cosmic microwave background, or sometimes called the CMB, it comes from a time 400,000 years after the Big Bang. So in astronomical terms, considering the universe is 13.7 billion years old, the WMAP is able to find heat that is from a long, long, long time ago. So, yeah, that ancient heat gives us keys to the early universe to see what it was like and how the life formed after the Big Bang. So, yeah, you can thank the WMAP for that. So, as this is the last season of Prietology and the last episode of Prietology, I thought that since it is the series finale and we conclude everything after 4 years, let's take some time to reflect, and here are the best moments from Season 1 and Season 2 of Prietology.
Hi everyone, welcome back to Dprieto TV. I know with this coronavirus pandemic, these are difficult times. So, since a lot of schools are out and not a lot of people are learning a lot of things, I was thinking that I could bring my knowledge of science, because I love science. It's a beautiful thing to study. So, I was thinking I could bring my knowledge of science to you guys and, well, teach you guys about science. So, basically what I'm going to do, this, as you saw in the title, this is Season 1, Episode 1. So basically today, each day I'm going to do lessons based on like different topics. So today you saw is the basics of chemistry. So that's what today's episode will be about. So, I don't think there's any other aspects, so let's get started.
Atoms inside a solid are very slow, so you can see my model atom here. You can see off the camera, can you see it? Okay, so this is the experiment of the day. So, each class, at the end of the day, I'm going to show you guys an experiment that you guys can do at home.
Hi everyone, welcome back to Dprieto TV, and welcome to the new episode of Prietology.
So the metals during metallic bonding, they're held together in a lattice of positive ions. An example of a lattice, if you don't know what a lattice is a badminton racket is a good example. As you can see here, this is like, a lattice is basically like this square checkerboard kind of pattern.
Okay, so the next term... Who is this?
Hi, I'm secretly tuning into your lesson because I hacked your network.
Okay. Well, why would you do that? That's just my only question.
I called you because I have a question from your lesson.
Okay, well, what's your question?
Okay, so the question is, how are acids and bases related?
Okay, well, that's actually a really good question. Let me explain.
See, oh boy, this is getting full really fast. Oh boy. Oh, mackerel.
Put more in.
Okay, no, it's overflowing. Hi boss. Does that mean we get to blow things up today? Absolutely not. Not in here. What about like dissolving or setting things on fire or exploding or lasering or whatever there is in chemicals? No, just no. Okay, how did you even get inside my home? You're supposed to be at the lab. Well, yeah, how did I get inside? Man, I'll just leave you. But sorry, boss. No more chemistry lessons for season 1. Our next topic is physics. Hi everyone, welcome back to Dprieto TV and welcome back to Prietology. We are starting with season 2, and if you haven't watched Prietology, I recommend watching the entire first season, which was about chemistry, up here. On 3, 2, 1. Alright. Let me think. $20 million joules is in 100 grams of chocolate, so basically it has a lot of energy. Well, looks like we covered all our key terms for today, so let's get on to experiment of the day. Together, it'll create an explosion in the universe so big it releases a flash of raw energy across the universe. This is also, I think a photon is also on the standard model. Here's a picture of the standard model right here. I think it's on it. Oh well. Come on, screw. Screw. Come on, it's not working. The topic for season 3 of Prietology is biology. We're gonna get it's interesting to see what early Prietology was back in season 1, season 2. I look so young. That was 2020, early 2021. Sheesh, that was a long time ago. Season 1, season 2 was chemistry and physics. I love those seasons. Those were fun. We did the experiment of the day. Unfortunately, we aren't able to do experiment of the day anymore because doing experiments in space is kind of hard for me because I don't have billions of dollars. Well, as we were wrong, let's talk about dark matter. Dark matter is a mysterious thing. We don't know whether it's a type of matter or it's like an ordinary, weirder version of matter. So it's still kind of unknown what really dark matter is. All we do know, or a good amount that we know, is that it makes up a lot of the universe. A lot of the universe that we have today is made up of dark matter. Whether it's ordinary matter or a very special version of matter or its own version, still yet to be seen. So one thing that scientists were able to do, a breakthrough in dark matter, is that we were able to map the universe's dark matter, the visible universe's dark matter, back in 1997. So we know where most of the dark matter in the universe is, and the thing about dark matter, it's hard to find. There's actually something interesting in the book that we have. This book, where we get a lot of notes from Prietology, how I'm able to make these, is that it's actually a really funny thing what they did. Is that they mentioned like scientists, astronomers, they put dark in front of something they don't understand in space. So like weird types of matter, dark matter. A weird type of energy, it's not understood, so let's put dark in front of it. It's kind of funny. So yeah, so dark matter is still not clearly understood. It's hard to detect since it doesn't interact with any type of EMF or electromagnetic radiation. So yeah, so it can't react with radio waves, microwaves, infrared, light, X-ray, gamma ray, anything, or ultraviolet. It can't react with any of that, and that's one of the reasons it's hard to detect. So the way we're able to detect it is with very, very special instruments that we have that cost billions of dollars, which I can't show you. So they can be seen pulling on regular matter with its gravity. From what people have seen, they think it's denser and has a greater gravitational pull than regular matter. So if we see matter like clumping towards something, then yeah, there we go. We might find dark matter. It can also be seen spinning galaxies faster. If we see a galaxy that's spinning faster than it usually is, it's probably the gravity from the dark matter pulling it and making it go a bit faster. Or another way to see is that it makes light warp around invisible things. It doesn't glow. The dark matter doesn't glow because remember, it can't absorb any electromagnetic frequencies. It makes the light bend because of its gravity, and that is part of the theory of relativity, which means that light is able to be bent, and yeah, it's kind of it. That one thing that dark matter does is it also keeps galaxies from breaking apart. People think that without dark matter, we wouldn't be here. We would be flung off somewhere in space, and yeah, dark matter is the glue that holds our galaxy together. Fun fact, earlier I mentioned that it makes up a lot of the universe. It makes up 23% of the visible universe that we know today. So that is very, very far. That is a lot of dark matter that makes up the universe. It might seem like a little bit, but without dark matter, our galaxy would fall apart. So, thank you, dark matter. Alright, this might seem familiar because we kind of talked about it-ish in the first one. We had dark matter, but let's talk about the penultimate term in all of Prietology, dark energy. This is more unexplained. We know more about dark matter than we do know about dark energy. It's an unexplained force that partners up with dark matter, and it envelops the universe, and it tries, this is weird, to pull it apart, essentially. That's really what dark energy is. We don't really know what it is. Besides that, it's trying to pull apart the universe, and as it expanding, all the expansion is trying to pull it apart. That's the part about dark energy, and it envelops the universe. It's not really like a form of like energy, not like thermal energy or nuclear energy or chemical energy. It's more like a force, although work is force times distance, so I guess that's how they can classify it as an energy. So the thing about dark energy, it was very crucial in the first seconds after the Big Bang and somewhat responsible for its creation of the universe. Without dark energy, remember, like I said, envelops the universe, we probably wouldn't be here today. This is the fabric, well, some part of the fabric, not exactly. This is some part of the fabric that makes up our universe. Without dark energy, we would not be here right now. So, super crucial after the Big Bang. The thing about dark energy, sorry, not get this mixed up. Like I said, it's pulling the thing apart. It's because it has something very special called anti-gravity. Anti-gravity, we've heard in like sci-fi or like superhero movies, like anti-gravity. It's like, whoa, I can like float off the air. No, this is anti-gravity in a scientific way that somewhat exists, somewhat is not explained yet. So, if you have the pull of gravity from like a star or some massive celestial object, and dark energy, since it has anti-gravity, works in the other direction. It repels gravity. So that is how it is able to pull the universe apart. It's pushing everything in, but at the same time it's pulling it apart that way. It always repels the force of gravity, making it anti-gravity, which means that it is pulling our universe apart, like I said. So, astronomers were looking at supernova explosion and saw that the universe's expansion because of that was speeding up. If it's expanding like this, dark energy is trying to pull it apart, which means that with that supernova explosion, the expansion is speeding up because dark energy is trying to pull it apart. Fun fact about dark energy is dark energy particles, which we haven't discovered. Well, we haven't like discovered-ish yet. We haven't like seen them. It's kind of like dark matter is not visible to us, since it literally envelops the universe. Dark energy particles act against gravity's pull, like I said, to make something called anti-gravity. So, gravity goes this way, then anti-gravity will go that way. It always repels the force of gravity, which means that it is pulling apart our universe, but trust me, we'll be fine. For now. Probably in the next billion years it might happen, who knows. So, we've already reviewed Prietology Season 1 and Season 2. Let's take a look at the best moments from Season 3 and Season 4, and then we're on to the final term. Well everyone, we're back. Welcome back to Dprieto TV, and yes, Prietology has returned. We are here to start Season 3, and as you can see by all the plants and stuff that surrounds me, let me move this over here, we're doing biology. Also, big announcement for this season that is going to change. There's not going to be an experiment of the day for this season. This episode, however, will not have one term, will not have two terms, but a record-breaking 19 terms. No, don't mess with them. Like, no, this is, I beg you, I actually restrict you from touching this animal. Please do not touch it. It's a real big organ, makes up 2% of your body weight. That's a lot. So basically, take your weight. Mine's is, oh, hold on, I have a calculator near me. Hold on. The liver is 1 kilogram in my body. We're talking about these. These are flowers, if you didn't know them. Pretty cool things are the things that flamenco dancers hold in their mouth when they dance like this. Yeah. Adenine, guanine, thymine, adenine, mining,
I don't know, I have to check that later.
Alright, all the proteins are being made, everything's good. Sir, we have some new genetic code. You might want to check this out. Yes, alright, thanks, genome. Where is it? There's nothing on this paper. What are you talking about? Where's the code? How am I supposed to do transcription translation with this? I don't know, boss. That's what Protein gave me. If you want, I didn't do anything. You could ask Protein. I was just given it. I was just told to give it to you. Seriously? Fine. Protein, get over here right now. Yes, boss? I was just trying to transport these ribosomes so we can just go do more functions. What's the problem? Oh, problem? You want to know what the problem is? Look! Where is the code? It's empty. The base strips aren't even there. What are you expecting me to do? Not transcript and translate? The cell will die. What? What are you talking... Did Genome tell you this? Because if he did, he's a liar. I did nothing. I'm just telling him. He's the one who has to write the code down. I just transferred ribosomes, okay? Yeah, I just transferred ribosomes. But it's entirely his fault. Me? You're calling me a... Did any of you call? Well, everyone, welcome back. It is Prietology Season 4. Collisions between plates, because plates don't just go smoothly like F1. Like, remember how in Formula 1 when I played, there's collisions all the time. Beat him down the straight. Let's beat him down the straight. Come on. Push me off. No. There's 4 cars everywhere. Plates are exactly like that, except they're not cars. Before we move on to the next term, I want to do the demonstration to see how, like, the sun's heat, the sun's light affects like things like latitude, longitude. So yeah, let's dim the lights. Alright, that's my best interpretation of the US. Now let's make Florida. Florida would essentially go right there. The Pacific, the Atlantic, the Indian, the Arctic, and the usually forgotten one that no one remembers, the Southern Ocean. Right there. There we see a picture of a front chart, so like the weather in the coming area. The lines with the blue triangles, that indicates a cold front, and the line with the red like semicircles is the one that indicates warm front. Season 5 will be about... I'm gonna do an extended drum roll. We're heading and we're reaching for the stars. We're going to talk about astronomy. Wow, wow, wow. Prietology has evolved so much since we began it in 2020. The reason I began it is that during COVID, I really had nothing to do and school was out, so I might as well have brought my scientific knowledge to you. But we have come so far over so many years. We've done 4 seasons. Now we're about to conclude the 5th season. This is the final term of Prietology history. Enjoy this, everyone. This is the final term. This is the final term we'll ever do, and we are going to talk about one of the most crazy concepts really, that we've ever talked about on this. This is the thing that controls all of the universe, the thing that makes the entire universe and possibly beyond the universe. The space-time continuum is defined by something called space-time. Space-time is the very 4-dimensional fabric of space that makes up the universe. Yes, you heard me right. 4-dimensional. 4 dimensions. It says, have you ever heard someone talk about, like, ooh, the fabric of space, the fabric of the universe? They're talking about space-time. Space-time is a weird concept that was defined by someone. I'll get to that a bit later. So, how it works is that it can warp. It warps. So, like, if it's, say we have our space-time fabric right here, and if it warps down like this, gravity is going to be pulled like that. It's kind of like a fabric. That is why it's called the fabric of space. Because let's say you have, a good way to explain it is, let's say you have a stretched out fabric, and you put like a metal ball in the center, but then if you pull the fabric underneath, the ball is going to fall towards it. It means that gravity is created. That is how gravity is created. Gravity bends towards folds and warps in the space-time continuum. Like I see, we will never be able to even like perceive time, because we can only see in 3 dimensions. Our brain can only process 3 dimensions. Time is a 4th dimension that we will never be able to see and that we will never be able to perceive. We can only perceive it through math and like other calculations and weird other stuff. So, how time, because of the space-time continuum, essentially works is that time travels slower and slower for things traveling close to the speed of light. So a photon travels at the speed of light. That's what makes them all lights. They're massless particles that travel at light speed and then create all the light that we see today. they travel slower and slower. Time, relative time, works for them slower because they're traveling so fast at the speed of light. So, because of this, time is considered the fourth dimension, along with you have your length, your width, and then your height. Time is the other one. Things that travel faster to the speed of light have more of a relative time, a slower relative time compared to other one. So, because of space-time, it allows scientists to describe things like the orbit of far-off planets, and since those far-off planets, the relative time of those planets is slower than our relative time because of perception and other stuff. So, and it also allows for scientists to even like describe the word relative time for everything. Everything in the universe has a relative time based on the space-time continuum and its speed close to the speed of light. Whew. I just tried to explain something wild to you, something that some college students spend years investigating, years of their life investigating. But yeah, that's a very, very, very elementary version of it. It's like scraping the surface of space-time. And yeah, that is the space-time continuum that envelops our universe, and who knows what will happen in the future with the space-time continuum. Fun fact, this is something that changed the future. All this stuff that I just described with the space-time continuum make up something called Einstein's theory of relativity. Relative time, how relative time travels slower for things that go faster than the speed of light, or things that approach the speed of light, time goes slower. That is the theory of relativity, and the fact that we have our fabric of space, and that if you pull down on that fabric, you can create gravity as it bends towards, light can bend towards that. Yeah, that's the theory of relativity. That's it. C'est fini. It is over. That is Prietology, done and dusted. What a seasons it has been. Space-time was our final term. Yeah, now we've concluded. That was the end of Season 5. We are done. We have completed 5 seasons of Prietology. Let us go through the best moments of Season 5, and then we'll conclude the whole series. Well, hello everyone. Welcome back to Dprieto TV. I hope you like travel tidbits, but finally, since January, we are back with Prietology Season 5. Uranus, not Uranus. Ha. It got hit sideways, and now it's spinning like this, but now it's tilted like this, and it spins like this on its axis sideways. Halley's Comet. I forget who it's named after. Hold on. I'm looking at the astronomy book that we have. Well, it technically wasn't created, but its orbit was predicted by Edmund Halley in 1758. You know some constellations. You have Virgo, you have Gemini, you have Scorpio, you have Aquarius, you have Pisces, you have Taurus, you have Aries, Cancer, Leo. They shrink down like a funnel. They get thinner and thinner and thinner and thinner and thinner and thinner until they shrink into a point, an infinitely small point, which is called spaghettification, or being spaghettified. As you know, spaghetti is a noodle. It's a very long noodle. Yeah, like I said, happy holidays. Christmas time. As you can see, my place is a bit decorated. As you can see, there's a stocking here. Hopefully there's something in there by Christmas Eve. So yeah, it has taken some of the most beautiful pictures, won awards for some of the most beautiful pictures of space you've ever taken. This was taken by Hubble, this one. Next episode is the final episode of Season 5 and the final episode of Prietology in general. It's the series finale. Do not miss it. It'll be a full-fledged finale. We'll celebrate the past 4 incredible years of Prietology and the 5 seasons that we've been able. I cannot tell you guys that 4 years ago, doing this, all this for so long of a time, unfathomable. Unfathomable that I would be able to do this for so long. After I made the first Prietology lesson, I'm just like, okay, this is a good video. And then I saw how popular it became. I'm just like, okay, I'll keep doing this. I'll make a few more videos. And then just like, all right, we finished all the chemistry. Do we want to do physics? And then we finished that. Do we want to do biology? Then earth science. And then now astronomy. We've done 5 seasons of this, guys. This would have never, ever, ever, ever been possible without you guys. I want to thank you so much for your support over these past 4 years to support Prietology. You guys have done amazing. We've talked about chemistry, physics, biology, geology, or planet Earth science, and astronomy. We have done so much over the past couple of years to do so much in Prietology. We have talked about we have talked about chemistry, physics, geology, astronomy, from acids and bases to nuclear physics to cell biology to the layers of the earth to the solar system to space-time. We have done so much. We've covered a lot of scientific knowledge and terms. Who knows what lays in science for the future? I hope I've inspired you guys to maybe at least consider a career in science. I hope if this has encouraged you to to start pursuing a career in science, cool, could pursue it. I want to pursue a career in science. I want to become an aerodynamicist. We didn't talk about aerodynamics because it's such a super complex topic in physics. But yeah, if this pursues you to do physics, do it. We cannot wait to see what the future of science looks like. And if it's with you guys, that would be absolutely amazing. We have done so much in Prietology over the past 4 years. Here's the stats. We've done 5 seasons, 30 episodes, including this one, 222 terms, including this one, and this is the best one, over 530 minutes of content in Prietology. We have done so much of these past 4 years. I would have never ever been able to do it without you guys. It's going to be sad leaving this. This has been a part of my life. I've circled my life around this, having to do this like once every weekend, balancing with gaming videos and travel and other miscellaneous videos that we do. But yeah, now that we're no longer doing Prietology, now that we are finally concluding it here in the series finale, I'll find something else to do. Don't worry about it. So, some announcements. Now you're probably wondering, David, what's going to happen to Prietology? What's going to happen to that? What I'm going to do is I'm going to divide the Prietology playlist into 5 separate playlists, each of them for a season. So if you want to binge season 1, season 2, 3, 4, 5, and learn about chemistry, physics, biology, geology, or astronomy, go ahead. And I'm also going to make compilation videos. I'm going to put all of season 1 in one video, like maybe it's like a 2-hour, maybe long video. All of season 2, all of season 3, all of season 4, all of season 5 in one videos, and that is coming soon in the future. I will make that soon. So, I hope you enjoy that for the future, the new Prietology. I'm reshuffling it. But in terms of new videos, here's what's coming soon. On April 29th, we are continuing the Cuphead Blitz. The Cuphead Blitz will continue on April 29th with the 14th. Week after that, on May 6th, with Cuphead number 13, with Cuphead number 15, and then on May 13th, a week right after that, is the final Blitz with Cuphead number 16. So, that is all coming soon. Get excited for that. So yeah, that's all coming soon for Prietology. For Prietology, that's kind of it. We're done. Thank you guys so much for supporting Prietology over the past 4 years. Whether it was watching it, making chapters for the videos, yes, I see some of you have. Thank you for doing that. That helps a lot. Or subscribing, or liking a video even, or even putting a comment. I've seen some of you guys put comments under the videos. Thank you so much for supporting Prietology in any way you guys support it. Thank you so much for these past 4 years. I've super enjoyed making these videos. I'm a science buff if you haven't seen me making these videos over the past, 30 episodes of this series. Thank you so much for supporting this, guys. I wonder what the future will bring, not in just terms of the channel, but in terms of science. I hope that you guys pursue a scientific career. If you don't, completely fine. But thank you so much for Prietology for the past 4 years. Thank you, guys. See ya.